Okay, looks like we are live, and I want to welcome everybody to Standing for Truth. On Standing for Truth, we focus on the truth of biblical creation. And it is a privilege to have Mike Oard back here with us today for an incredibly important show. Now, I want to point out to the audience, this is Mike's third time on Standing for Truth, and I have linked his previous presentations in the description box. The first presentation focused on the recessive stage of the flood, while the second focused on the ice age. So please check those out. Tons of great information. They are definitely a must watch. Today, we will be focusing on evolutionary challenges debunked. And I want to thank Mike for giving us his time. Mike, I know you're busy, so I really appreciate it, Mike.
You're welcome.
If you... I want to point out to the audience, they can tag me with their questions. They've already been doing so. Just make sure you're tagging me at Standing for Truth. We will have a short audience Q&A after the presentation. So, Mike, since this is your third time here, maybe I'll just hand it over to you. You can have the floor. If you wanted to give a few words of introduction, you can do so, and then we can kind of get right into the presentation.
Well, the Lord has led me over 45 years of creation research to answer or attempt to answer challenges to the biblical worldview. And of course, I work in earth science, so that's what I've been doing, like the ice age that I talked about last time. What about woolly mammoths, dinosaur tracks and eggs, which I will talk about. Anyway, I've titled this Reasonable Answers to Earth Science Challenges. The reason I added reasonable is because it's in the past, these are reasonable answers and they could be wrong with further data. But anyway, I think they're reasonable. I can't say they're exactly a fact, but they're reasonable answers to the biblical worldview. So I read... try to keep up with about 50 earth science journals. And by the way, there's many, many more. It's a time factor for any more. And I come across all kinds of challenges. Actually, there's hundreds of them. Some of them I've worked on myself, like how does the flood cover Mount Everest? I've done that one. This is a short list I made in about 5 minutes off the top of my head. But if I spend a year, I could probably get a couple hundred. To me, they're research projects. And we do have answers to many of these already, and some are we don't. We have partial answers, partly because it takes a long time for some of these things to be able to give answers. Here's another list. I've worked on some of these. And these challenges have really affected a lot of people over the years since they assumed the earth was old in the late 1700s, throughout the flood, then added evolution in the middle 1800s. So these challenges have produced some really bad fruit within the Christian churches. It's caused many to doubt God's word, caused tens of thousands of atheists and agnostics, if not millions, caused tens of millions of Christians to think what they're hearing or reading is a fact, so they try to fit it into the Bible. From my experience, you don't have to do that. The Bible can defend itself. It's enhanced the local flood myth. It's resulted in a mass exodus of the youth, as a number of polls show that after college, many Christians, a majority of Christians, leave the faith for various reasons. The biggest reason, from another poll, from Answers in Genesis, indicated that the age of the earth question was the number one issue, and evolution was a secondary one. So these things, we're just not talking about academic things. We're talking about things that affect many people. But a closer look at challenges. Many do not realize that most of these are also challenges to evolutionary geology. A lot of people wouldn't know this because a lot of times they papered over their difficulties with another hypothesis, and it sounds reasonable. But when you dig into it, you find out that many of these same challenges, they can't answer either. Also, there's not enough known in the earth sciences. There's such many unknowns. A lot of people don't realize this. In fact, we have probably tens of thousands of earth science researchers, and researchers always do research on questions and unknowns. This just gives you an example. The biggest unknown is what's below our feet exactly. We can tell a lot of things with geophysics, but still there's a lot of guesswork in all this stuff. Many do not know that the creation flood ice age model does have solutions to many of these challenges. Just look on the websites, for instance, you can find answers. Some challenges take a long effort, and some will not be are not able to be answered now, so we can't have every question answered, but we have a lot answered to give us faith that there are answers out there. It's either a long effort or there's just not enough information. And one of the problems is the lack of workers and funds. Those are some of the closer look at challenges. When I read challenges, well, I read them all the time, I am like the Bereans. I check it out. And my theme verse is that examine everything carefully, hold fast to that which is good. I'm going to hold fast to the Bible as God's word, and Jesus is my Lord and Savior. But I'm going to examine everything carefully that I read in science. One thing you'll find out when you examine these things is there's observations and there's interpretations. The real issue is over the interpretations of the observations, not the observations themselves. You need to remember that anytime you're reading secular literature. Also, 1 Peter 3:15 says that we need to set Christ apart as Lord in our hearts and be ready to give an answer to anyone that asks us the hope that's within us. Yet we do it with courtesy and respect. In other words, we need to have answers to people. And we can't answer every question, of course, and that's why we have those great websites, the books and DVDs out there to help us. So I got, George gave me 2 challenges he wanted me to answer or to provide a reasonable answer. So I'll do those 2 first, and then I'll do some ones that I've worked on. And then I'll let you in the audience ask questions, and hopefully I can get a reasonable answer to many of them. Anyway, the challenge of how sedimentary layers form rapidly. Well, there's, I think, several mechanisms. Turbidity currents. We know that turbidity currents, they have a lot of water in them. They're not like debris flows, which have a lot less water, but they flow down a slope and then spread out long distances. And when they do, they kind of segregate into different layers for some reason. I haven't read yet why they do this, but it's generally a coarse and a fine layer, and there's a number of them all at once. But you can imagine during the flood, you had huge turbidity currents, probably 10,000 times the size of the little ones we get today. And you could possibly form rapid layering over, say, 500 feet really quick. Another mechanism, which could be similar to turbidity currents, is that when you have particles of different shapes, mass, and or density, when they're flowing out, they will segregate by the differences of shape, mass, or density all at once. Like you have a coarse layer and then a finer one, and as the current moves, it deposits coarse, fine all the way, forming 2 different layers. This was illustrated and worked out by Guy Berthaud of France. Also, another one that people really aren't aware of is internal waves. We know that the ocean they have surface waves, but there's all kinds of waves down below in the surface, caused by a current going against an obstacle causing a wave, or any difference in density, or any other property of the water. You can cause a wave on it. Sometimes these waves, they will have sediment in it, and when it does that, it will sometimes even erode the bottom, and then they redeposit it, forming layers. So internal waves. And by the way, there's thousands of internal waves probably going on right now in the oceans. They're very common. And during the flood, I imagine with all the tectonics and chaos, there'd be millions of internal waves. So there's lots of ways to get layering rapidly during the flood. The second challenge that George wanted me to get into was mechanisms for rapid formation of unconformities. There's several types of unconformities, but he meant angular unconformities, where you have sedimentary rocks like this and at that angle, and then on the top you have it horizontal. There's an angle, maybe 15 degrees between those layers. That's an angular unconformity. Anyway, there's a classic spot in Scotland that was used in the late 1700s to put over on people and scientists that uniformitarianism must be true. Uniformitarianism, present processes over millions of years. And that was unconformities, a famous angular unconformity. But before I get to that, the main mechanisms of forming the angular unconformity is tectonics. During the flood, you had a lot of up and down motion of the sediments and the granites, and then you had rapid currents. So as you bow up, say, a ridge, you can have a current sheared off, and then another layer lay down on top of it, all in rapid succession. This is what you expect during the flood. So we should expect many angular unconformities. Anyway, I thank Taz Walker of Creation Ministries International in Australia for this section. It's a kind of an icon of geology, unmasking Siccar Point, secular geologist sacred site. It's right there in Scotland. That's where this senior moment, his name skipped my mind, but I'm coming to him. It's where he claimed in the 1700s that that can't be explained by the flood, therefore uniformitarianism must be true. This is Siccar Point. You can see, it's kind of hard to see, but you see over in this, you see vertical strata that was once horizontal and now it tilted up like that. And there's horizontal strata on top of it. Here it's not tilted vertical here, but here it is. And you can't hardly see it too much, but I'll show you other pictures. Hey, James Hutton, yeah, called the father of modern geology. Anyway, you can go visit there. It's kind of a special geological site that many people visited. James Hutton Trail opened in 2006. You can walk it. It's on Hutton's farm. Anyway, Hutton ignored the Bible and is generally regarded to approve the Bible got the age of the earth wrong. Of course, he didn't. He assumed it. Here's a better picture of it right here. You can see the vertical sedimentary rocks, strata. And here's the horizontal sedimentary rocks on top. Vertical, horizontal, boy, that's quite a change. Well, you know, when you look at the signage at that site, you actually see how they think it was done. And this is exactly how I think it happened fast in the flood. You had the folding of strata. We had some vertical strata fold like this and like this. This is hard to see. It's on the right side of my screen. And then you fold the strata and then you shear it off. Now, with uniformitarianism, you don't expect really fast currents. How are you going to shear all this off to a generally flat surface? Big problem. You can do it in the flood. Then after you shear it off, you deposit sediments on it, and then it deforms a little bit. So that's how supposedly Siccar Point was formed. And most people that at this time thought the world no older than a few thousand years. Hutton realized that geology time is virtually unlimited, but he assumed it first. And here's kind of a block diagram of it, or an illustration that Taz did. See, old red sandstone, nearly horizontal on vertical Caledonian strata. And it's generally flattened to a nearly flat surface. And if it was long periods of weathering, you know, I mean, they give these things millions of years for each formation and between these formations, you see. You should have huge weathering and big, deep valleys, but Taz only made little tiny valleys and ridges in here. And that's what you should expect weathering, but you don't see that. You see it's cut flat. And not only that, you find breccia layers. Breccia are angular rock fragments in it, indicating that you had a fair current that probably formed this flat surface and eroded some of it, leaving it in the bottom layer as angular rocks from the substrate, indicating catastrophic action. So that's how unconformities form. So let's move on to some challenges that I've worked on. I haven't worked on this one too much, but my late friend, Harold Coffin, did. He spent 30 years working on the so-called Yellowstone fossil forests. And this is considered a major challenge in geology. Well, here's some pictures of it. Notice the sediments in it. It's actually volcanic breccia. They're volcanic breccia flows that are spread. It's called the Absaroka Volcanics. They're spread over 6,000 square miles and 6,000 feet deep, and then deeply eroded after they're all deposited. And within these, you find these vertical trees. You find horizontal ones too, I might add. A number of vertical trees up and down a cliff like this. They're petrified. By the way, some are not quite petrified. I've seen some that in the middle seem to be unpetrified. Anyway, this is at Specimen Ridge. And here's kind of the picture that geologists tell people. This is a diagram, a crude diagram, where they say there's been successive forests grow. And they're overwhelmed by this volcanic debris flow, or lahar. And it took, the forest is 500 years old to start with, because some of these trees are 8 feet in diameter. And it overwhelmed it, and then it took 500 more years for it to grow. And then so we got about 1,000 years in each layer, they claim. 1,000 years. And on Specimen Ridge, which is in Northeast Yellowstone Park, which is only an hour and a half from where I live, by the way. As you can see, I'm wearing a nice Yellowstone Park t-shirt. There's about 24 levels there. So that represents 24,000 years approximately. But there's another place in the Northwest Yellowstone Park called Specimen Creek. They're two totally different areas. Here's a quick picture. When you even see one vertical petrified tree at an angle, but if you got to look close to see them up here, but there's about 65 layers here up this cliff. 65. And that would represent maybe 65,000 years. So the geologist has been parading this around for dozens of years. And here's an example of who was once a young Earth creationist that said this example made him lose his faith. It was Ronald Numbers. He talks about it in the second edition of the book, The Creationist, 2006. By the way, this book is just tremendously biased and lots of errors. Anyway, he says on page 13, born and reared in a fundamentalist Seventh-day Adventist family of ministers, I learned George McCready Price's version of Earth history at my parents' knees. I subsequently attended Adventist church schools from first grade through college, and though I majored in science, I saw no reason to question the claims of strict creationism. In fact, I do not recall ever doubting the recent appearance of life on Earth until the late 1960s while studying the history of science at the University of California at Berkeley. I vividly remember the evening I attended an illustrated lecture on the famous sequence of fossil forests in Yellowstone National Park, and then stayed up much of the night with a biologist friend of like mine, Joe Wiley, first agonizing over it, then finally accepting the disturbing likelihood that the Earth was at least 30,000 years old. Having thus decided to follow science rather than scripture on the subject of origins, I quickly, though not painlessly, slid down the proverbial slippery slope toward unbelief. He's considered an agnostic, but this last part of the quote, notice he decided to follow science. Well, he should have followed scripture, really. But he didn't really follow science. This was not science. This was the interpretation of those petrified trees in Yellowstone Park. It's an interpretation. My late friend Harold Coffin has spent 30 years researching this, and he's published in the Seventh-day Adventist journal Origins and elsewhere a good solution to this problem. Before Ronald Numbers published a second version in 2006. In fact, I looked, and Ronald Numbers doesn't even reference Harold Coffin or any of the new work done on this. Poor scholarship. Anyway, what you find there is that, first of all, trees need soils. There's no soils. There's organic layers. And in those organic layers, which are either paper thin or maybe about 5 inches thick, at maybe the thickest, you find organic matter that's not decayed. You find fossil leaves, you find needles, but no soil. They're not soils. So there's no soil. Also, when you examine the types of trees, you find out there's about 200 species of trees from tropical climates to cool climates all together there. So there's other problems, many problems that he should have known this, especially for a second edition, and realized that he made a mistake long ago when he accepted this and claimed this is why he lost his faith. There's probably much more to it than this, but this is what he said. So these challenges have some big effects on people, and they need to learn how to deal with them, to think through them, look at the observations and stick to scripture and look and challenge the interpretations. Okay, let's move on to another one, which I have worked on a fair amount, the challenge of dinosaur tracks and eggs early in the flood. So many people think the early flood was chaotic everywhere. It was chaotic in a lot of places. The more I know about the flood, the more chaotic I've seen, but there's calm areas, and a lot of things happened early in the flood. So this is a challenge that they give us to answer. But the secular scientists have their own challenges when it comes to dinosaurs. They think dinosaurs are on their side. They can use it to influence people to believe in evolution and deep time. But they have a lot of challenges. I'm not going to go into these. These are just mostly a summary of challenges I worked on because I want to allow room for questions and answers. Anyway, they find they don't have any answer to the origin of the dinosaurs or how they went extinct. They have over 100 theories on how they went extinct. Also, they find polar dinosaurs, a lot of places, Antarctica, Alaska, Spitsbergen, Siberia. Also, there's a lot of desert dinosaurs, a lot of three-toed dinosaur tracks in the desert, supposed desert. Well, what are they going to eat in a desert? Maybe these aren't desert sandstones, these dinosaur tracks are. Maybe they're water-laid after all. And one of the biggest one is the dinosaur soft tissues issue, which the Creation Research Society, their iDino project, is spending a lot of time and effort to really research. There's lots of dinosaur soft tissue, and from what we know, it can't last more than thousands, maybe 10,000, 100,000 maybe years at the most, but yet they claim these are hundreds of billions of years old, some of this. And by the way, they're finding soft tissue in other organisms besides dinosaurs. This indicates that their millions of years is untrue. Anyway, when you look at dinosaur tracks and dinosaur material, you'll find it's at the top of the continental layers. It's usually on top of thick sedimentary rocks. And from areas around it, erosional remnants or eroded anticlines or other features, the rank of coal, you can find out a lot of sediment was eroded to get down to the level of the dinosaurs. And that's Roy Holt called that the Erodozoic, and that's actually retreating stage erosion. You have the flooding stage for the first 150 days where the waters rise, and then the retreating stage where the waters fall for 221 days. And during that time, you eroded a lot of the continents as the continents were coming up out of the floodwaters and the ocean basin sinking. Lots of evidence for this. By the way, one of my latest research projects is to try to determine how much sediments is left on the continent and how much was eroded off. And I'm getting some fantastic numbers based on new data of how much ocean sediments and how much sedimentary rocks are left on the continents. Thanks to the work of Tim Clary of ICR, he figures there's probably about 2,300 meters of Phanerozoic sediments, but there's another 1/3 of Precambrian sediments. So altogether, there's about 3,000 meters of sedimentary rock on the average on the continents. It varies a lot, from 0 to maybe 20 meters or more. And in the ocean, they've determined how much. And most of this, I believe, is that we find in the ocean was eroded during the retreating state of the flood. And based on maybe half the deep sea sediment being post-flood, there's lots of mechanisms to get rapid sedimentation during the ice age on the bottom of the ocean. I estimated there's 1,800 meters that was eroded off on the average on all the continents during the retreating stage of the flood. We're talking about massive effects. So at the peak of the flood, there was an average of 5,000 meters of sediment on the continents. That has a lot to say about the early flood, which I'm in the process of exploring what all that means right now. But that's kind of got off myself on a tangent. But anyway, the dinosaur are on thick sedimentary rocks. And then when you look at the tracks, you find a lot of unusual features. Assuming they were made in a natural environment, it's unusual. For instance, tracks of likely poor swimmers are rare. For instance, Stegosaurus, Triceratops, and Ankylosaurus. You wouldn't, because these aren't just built for just floating very well. That they likely died early in the flood and didn't leave tracks. Then another really key fact is practically all tracks, and there's millions of dinosaur tracks now. They're finding them fairly frequently. Practically all from adults and older juveniles. Where are the young? Well, when there's a catastrophe in, say, Africa, where there's a lot of elephants and other animals, you find tracks of not only the adults, but also babies. Lots of babies. So the fact that they're not there indicates, well, what happened to them? It's not a natural environment. Possibly thinking that, well, maybe the young were too small to escape the floodwaters and got buried and destroyed, pulverized right away. Well, the adults and older juveniles were able to escape for a while. I'm not saying there's no baby tracks, I'm just saying practically all tracks are from adults and juveniles. There's some baby tracks, not very many. And also, when you look at the tracks, when you find 2 or more tracks as a trackway, they're practically always straight or gently curved. And they're always on a single flat bedding plane. They don't seem to ever climb hills to the next layer. They're always on a single sheet of the bedding, the top of a bed. And also, when you find tracks in areas with a lot of sedimentary rocks, and you find different layers of tracks, like in northeast Wyoming, there are sometimes the same or similar tracks on 2 different layers of strata, which in the case in Wyoming, they give it 3 million years apart. What's the odds of the same dinosaurs coming in the same area 3 million years older and making the same tracks, the same dinosaurs? Not very likely. So that got my interest up to, so I did further research. But so here's a few pictures. This is in northeast Wyoming. Here's you can see this straight track right through the 3-toed carnivorous dinosaur. There's other ones. Here's the plot they gave. This is the one I showed you right here. I imagine everyone can see my cursor. And then there's other tracks there. And then there's unusual egg features. There are also millions of dinosaur eggs in the strata. First of all, there's very few nest structures. There's probably less than a dozen that I've read about or heard about. A nest structure being a bowl where the eggs would be placed in it with the upraised rim. And there's also the eggs have no vegetation, indication of vegetation if they're laid on a flat surface. So the eggs look like they're just laid on a flat bedding plane. What's the issue with this? Well, they're finding out that dinosaur eggs are very porous. And if they're sitting there out in the air, they're going to dry out really quick and die. The embryo will die. So this is an unnatural situation. And here's probably one of the few good actual nests in the geological record on top of Egg Mountain, Montana. By the way, this so-called Egg Mountain is about 50 feet high. I mean, we have some good high mountains here, but why they called this Egg Mountain is beyond me. But anyway, the dinosaur eggs are in this plaster jacket, and here's the upraised rim around it. So that's a real nest structure. There's a number of them in the area, by the way. So I explained it by the beds hypothesis. BED stands for briefly exposed diluvial sediments. Diluvial is an old name for the flood, and they're only briefly exposed. Well, how does this work? Well, I have a block diagram to show you. Well, first of all, why were you going to form briefly exposed diluvial sediments? Because sea level, if you quote unquote, or flood level, is going to oscillate up and down during the flood at various scales, temporal and spatial scales. So a local drop in the floodwaters can expose a freshly laid deposit of sediment, and then a rise can cover it up and preserve it. So here's a nice block diagram. And they're in areas of thick sediments. So you had rapid sedimentation. So at T1 right here, at the top of the sediments are here, and you have rapid sedimentation. And then at T2, it's up to here. In T3, you're up here. You're getting close to the top of the floodwaters. But the floodwaters are oscillating up and down at various scales. And one scale, you have a local drop, and it exposes the top. This block diagram might represent an area 200 miles wide. But I'm just making a block diagram to illustrate the point. So there they would make tracks, lay eggs, and then another rise comes and covers them all up. See, you got to bury all this stuff to preserve it. Tracks are ephemeral. They're not going to last long, maybe of days to weeks. So you got to bury them rapidly. So the flood would be, this beds model would do it. So there's 5 mechanisms. I'm not going to go into these, except maybe one. There's 5 mechanisms that cause the floodwaters to oscillate at various scales. And of course, lunar tides, 2 a day, especially on a mostly flooded Earth, probably are going to be huge. And they're going to be twice a day. So that's one mechanism out of these 5. There might be more, but these are the 5 that I've found. Anyway, here's a little block diagram. Thanks to Melanie Richard for drawing this. Think of this area as maybe 100 miles wide. So it becomes exposed. Dinosaurs come on up, make tracks, lay eggs. Some die during a local fall, and then suddenly it rises again. And of course, the floodwaters are muddy. And so they're going to lay down a layer of sediment rapidly on what was done, the tracks, the eggs, the dead dinosaurs. And in this case, it doesn't have to be the case, but they stayed there. It could have been washed off. But then when you get another drop, they do it again, because it's illustrating that you can have multiple layers of these things in regions or local areas, which you do have. So this is how you would explain it. And by the way, there's a lot of associated features with these dinosaur tracks, like true mud cracks. By the way, you can form mud cracks underwater. They're called synergesis tracks or diastasis tracks, if I'm pronouncing them right, caused by generally chemical changes and things like this. Also, raindrop imprints. I could show you pictures of these. Bird tracks, coprolites, so-called paleosols, which I think are just, they claim a lot of paleosols in the rock record, but I think these are just chemical effects on the sediments. And so they claim they're paleosols. They can account for burrows and tracks of invertebrates and also even social insect nests. You can account for all these also with this. And if you want to know more about it, a lot more about it, you can get it out of this book, Dinosaur Challenges and Mysteries, how the Genesis flood makes sense of dinosaur evidence, including nests, tracks, nests, eggs, and scavenged bones. So that's one challenge that I think we have a reasonable explanation for it. Well, the secular scientists still have a lot of explaining to do on those unusual features of tracks and eggs. The challenge of the deposition of coal. You probably all heard that coal forms in a coal swamp over hundreds of thousands and millions of years. But that model has lots of problems, as many creationists have pointed out, especially when you think of a 200-foot seam of almost pure coal, which they claim represents 2,000 feet of peat scrunched down to 200 feet as it compresses. So why wouldn't you have other debris in there? Why pure? They have numerous problems with the origin of coal, but I think one good explanation is this beds model. And you got to kind of use a little imagination here. Anyway, here's a flat bedding plane, and during the flood, you had billions of logs and other vegetation ripped up and floating on the surface of the earth. And this log mat model can account for a number of geological puzzles, by the way, but that's a topic for another time. Anyway, these log mats, as the local sea level drops, the log mat or debris mat, vegetation debris will beach on top of the beds. And a local rise can, if it has sediment in it, could sedimentation so fast that the vegetation can't refloat, and it forms a layer. And even it's possible that dinosaurs can walk on top of this vegetation, making tracks in the vegetation, which ends up being tracks on the top of coal mines. Yes, indeed. Coal mines in Wyoming, Colorado, Utah, Queensland, and the UK have dinosaur tracks at the top of some coal mines, connecting it with this beds hypothesis. So as more sedimentation occurs and compresses the vegetation, coal forms. Coal forms around 150 to 250 degrees centigrade, depending on the rank. And like here, right in here, with thick sediments. And then during the recessional stage of the flood, you eroded a lot of sediments, exposing coal at the surface in many areas, like this right in here. In fact, for bituminous coal, which we have in Montana here, it takes about 2,000 feet of overburden to compress it and heat it up enough to form coal. 2,000 meters, according to the secular science, and then all that has to be eroded to expose it at the surface, like we have some mines at the surface right today. So that's how you can form coal rapidly in the flood, by the beds model. Also, they challenge us on the origin of caves and speleothems. Many of you have heard, it takes millions of years to form caves with these beautiful stalactites and stalagmites and columns. Well, let's check it out. But here's a column. Look how wide and how much calcium carbonate has collected there. And so that has the appearance of being millions of years old. But we need to gather the data first. And here's the challenge Arthur Strahler has challenged us a number of times in this. I consider this a book of research projects, but he got a lot of things right. He read a lot of our books and got a lot of our what we believe correct, but he got some things wrong too. Anyway, this was published in 1987. Here's his challenge to us. If it can be shown that either the excavation of caverns or their subsequent filling, that is with the stalactites called speleothems, must require a vastly longer time to accomplish than the post-flood limit, that is about 6,000 years, literal acceptance of the Genesis chronology is untenable. We turn first, he's going to try show the readers, to the rates of removal of limestone by the process of carbonic acid reaction. Okay, there's a number of problems with this. First of all, he has problems with carbonic acid even doing any of this stuff. As Emil Silvestru has pointed out in his book, The Cave Book, and articles he's written. Carbonic acid is formed by carbon dioxide in the atmosphere that combines with water, rains, and enters the soil. And then the soil has organic matter and the roots of trees, so forth. And so you build up soil carbon dioxide also that supposedly combines with water and seeps down into the limestone below. There's a lot of problems with that. Carbonic acid in the soil is neutralized within 1 to 10 meters down. If it goes down a crack, it reacts with the carbonates and soon is totally neutralized. It's no longer acid. And it stops. It's not going to do anything. So how are you going to go down, sometimes 1,000 meters down, and form a big cavern? Problem. And then they say they find out that the speleothems that they claim are millions of years sometimes can form pretty fast. And they're too young. I'll give some examples. They generally form at 0.1 to 3 millimeters a year on the sides, increasing on the side and on top too, for the ones that are stalagmite mites on the bottom. So one thing you observe with caverns is that it appears the cave opening was formed first with no speleothems, and the speleothems formed after that with no increase in the cave. If it's uniformitarian, cave openings and speleothems will all be forming at the same time, and you should have a mess in those caverns, not the beautiful stalactites, stalagmites, and columns that we do see. Anyway, from the book Cave Minerals of the World by Carol Hill, an old Earth creationist, by the way, from the University of New Mexico, and Forte, heard this statement a lot. This is not what they believe. This is what they commonly hear. A large stalactite or stalagmite takes millions of years to form. That's what people think. That's what they hear. But this is what they've discovered themselves. Caves take more likely only tens to hundreds of thousands of years. That's it. Not very long within their time scale, assuming uniformitarianism. But that's just the problem. They assume uniformitarianism. And this can be explained by the flood and the ice age. So we have two creationist challenges. First, form the opening. Secondly, fill that opening with speleothems after the opening is formed. Okay, the first challenge, the origin of the cave opening. Well, they've discovered recently, probably after Arthur Strahler wrote that about carbonic acid in 1987, that sulfuric acid dissolved as was the dissolution process in Carlsbad Caverns. By the way, I think there's about 300 other caves in that Guadalupe Mountains where Carlsbad Caverns is located. Anyway, they believe that all those were formed by sulfuric acid dissolution. You know, sulfuric acid is going to eat out limestone much, much faster than the weak carbonic acid. So at one time, they thought that 10% of the caves were what they call hypogenic, that is dissolved by sulfuric acid. But now, with more research, knowing what they're looking for, they now believe that more than 50% were dissolved by sulfuric acid. That can happen rapidly, and that can happen in the flood. And here's how I'm going to show you how I think it happened during the flood. But here's Carlsbad Caverns. Many of you have probably been there who live in the U.S. And down in there, they say there's massive gypsum on the floor. And here's a picture of it. It's about 12 feet thick. Gypsum is a product of sulfuric acid dissolution. See, that's the evidence. And there's other evidences for sulfuric acid dissolution besides gypsum. Anyway, here's a picture of it that I took in Carlsbad Cavern, about 12 feet thick of gypsum from the dissolution of the limestone by sulfuric acid. And here's a quote from a recent book published in 2017. There's about 700 some odd pages. And in the introduction, they say, more attention to hypogene karst. The karst is the limestone where the caves form and sinkholes form and other features form there. Hypogene means from sulfuric acid or any acid dissolution besides carbonic. I mean, there could be strong organic acids possible too. More attention to hypogene karst since 1990, and particularly the dramatic burst of studies in this field during the last decade, has changed our notion of hypogene karst from a curiosity to one of the fundamental categories of karst, at least a comparable importance with more familiar epigene karst. Epigene is a carbonic acid type. It's at least comparable in importance to these. But and he says later on, I think I got this, yeah, okay. Hence, the potential for the development of hypogene karst, that is by sulfuric acid dissolution, is immense, not only in the continental domain, but also in the oceanic domain. Moreover, even in Europe and North America, many areas have been recognized only recently to host hypogene karst, and its study is still ongoing. This means that the next edition of volumes under this title will be next editions of volumes under this title. In other words, you have a 700-page book going through all these in the world at that time. And he's thinking that more are going to be discovered, that we're going to need more books of this size. In fact, I think all these caves were formed by sulfuric acid or strong organic acids. How? I think it was the oxidation of sulfur or hydrogen sulfide based on the organic matter laid down in the flood. A lot of organic matter in the sediments. And the combination of water, oxygen, and hydrogen sulfide would form sulfuric acid, and that could eat out these caves. So here's a little block diagram of how I think it occurred. Well, first of all, the limestone has to collect, and it's a chemical. It comes out of the water as a precipitate, as it shows here. And it just comes out of the water and collects on the bottom. And as time goes on, it stops and you get other sediments on top of it. There's your limestone. Then in the retreating stage of the flood, when the mountains rose, the valley sank down, Psalm 104, verse 8, to drain the flood waters, and the continents rose, and the ocean basin sank. The limestone would expand and crack, and sulfuric acid would start running through the cracks and along some weak bedding planes, eating out holes in them. And then when it's all over, you got all these cavities within the limestone like this. And sometimes the planation, some of these places are planed. And like in the Guadalupe Mountains of New Mexico, which I need to check out a little more, according to a researcher, some of these, the planation surface at the tops of this mountain formed during flood runoff cuts through some caverns, indicating that caverns were being formed as the sediments were coming up out of the water, expanding, cracking, and draining, and eaten out by sulfuric acid. So you have all these caverns sitting there right at the end of the flood. So that's the origin of the opening, the cavern opening. Some of these are pretty good size. So during the Ice Age is when you filled them with the speleothems. The origin of the speleothems that decorate all these caves. And speleothems can grow fast today. Hill and Forte in their book said 0.1 to 2 millimeters per year on the average. And yeah, I'm quoting this again. How fast are they, Gary? We can predict a rate for a particular speleum, but on the average calcite travertine, that's a calcium carbonate on the speleothem, grows about a millimeter or two a year. A lot of times they grow a lot slower than that. Silvestro has thought this through, and in the Creation magazine article, Caves for All Seasons, he says they can actually grow fast, even if we assume uniformitarianism. Now let's consider one of the tallest stalagmites in the world in the Cave Armand in France, shown above. At 3 millimeters per year, which is a very generous rate, I might add, at today's rate, it would have reached its present 38 meters, that's huge, in only 12,700 years. Clearly, this contradicts the ages of hundreds of thousands of years obtained from radiometric dating, or even millions of years. And when I did research on caves, which I published a series of 3 articles in the journal Creation probably about 2 to 3 years ago, I discovered that some stalagmites in Belgium were growing 2.7 to 4.3 millimeters a year. An article in Creation magazine showed a growth ring in southern Siberia grew at 15 millimeters in 1 year. A man named Shaw did some research on all these things about about 100 years ago, and he listed 25 current rates that average 3.7 millimeters a year. There's one cave in Yorkshire that is growing 7.3 millimeters, and a lead mine in Iowa, 300 millimeters for a year for 3 years. I had to go check this out, and it took me to the verification of it through kind of an indirect route, but yet they verified this in a cave in a lead mine in Iowa. So they can grow fast. So how do they grow fast? Well, there's 6 main variables that determine stalagmite growth. The concentration of calcium ion in the drip water. As it drips down, how much calcium ion is in it. Number 2, the cave temperature. The warmer the cave, the faster the speleothem grows. Also, cave CO2. You want to get rid of the CO2 because as the calcium carbonate gets plastered on the speleothem, it gives off carbon dioxide. So you need to ventilate the cave. And so you got to get rid of the cave CO2. The more you get rid of it, the faster it'll grow. Also, the drip water flow. If it's very thin, it won't form a lot of on the stalagmite, which is the ones that grow from the bottom of the cave up. So if you have a thick drip water flow, you'll form the calcium carbonate rapidly. A thin, not less so. And so it depends on the film thickness and also the drip rate, how fast it drips. Also, a variable that is the relative humidity. But because of the evaporation of water in caves, the relative humidity is usually 100%. So most caves, practically all caves, the relative humidity doesn't do a thing. It's too moist. But it's interesting that in Carlsbad Caverns and those other caves in New Mexico, the Guadalupe Mountains, they're so dry that they're not growing except by relative humidity change. It's too dry for them to grow. In fact, it's huge. So what caused them to grow so big? That's a big problem for them. You have to have a much wetter climate. Hint, hint. Ice age, early ice age, wet climate. Anyway, so if the relative humidity is a little low, say only 90% or 80%, you'll cause calcium carbonate to form on the speleothems, and that's the only way they're growing in Carlsbad caverns today is by the lower humidity. The caves are dry, and New Mexico's a dry area right now. So based on these main variables, we can kind of look at it. First of all, it's not the calcium carbonate in the air that determines the amount of calcium carbonate that ends up, or calcium ion and carbonate ion that enter down in the cave, but also it's what's formed in the soil by tree roots and organic matter. They oxidize, so carbon dioxide forms in the soil. The carbon dioxide in the soil is usually 2 times that of the atmosphere or more, sometimes 3 times. You have a huge amount of carbon dioxide in the soil. So it's the soil carbon dioxide that is the important thing. And it depends on a lot of variables, but especially tree root respiration and organic matter left in the soil that oxidizes. So think of this. As the floodwaters were draining, a lot of soil with high organic, or dirt, I should say, or mud, with high organic matter in it would accumulate in a lot of pockets, and maybe in a lot of areas. And in that would be a lot of organic matter. And that organic matter, as it oxidizes, would form a lot of carbon dioxide, huge amount. And that would be available to form caves as the water combined with the carbon dioxide seeps down through the limestone, which you see below. This is a geological pattern for limestone right here. So it's a soil carbon dioxide in aqueous form that the calcium ion in the drip water depends on. And that depends, this is a summary of what I've explained in that block diagram. And that depends upon the soil respiration and the quality and quantity of soil organic matter, which at the end of the flood would be huge. And as trees start growing bushes with fairly good precipitation during the ice age, you're going to have a dense canopy and lots of plant material to form carbon dioxide. So you'd have high carbon dioxide early in the ice age. This all depends on the soil temperature, thickness, and moisture. And with a lot more plants growing, say, and maybe 4 times the precipitation in many areas like Southwest United States. This is from a calculation I once made, published in the Creation Research Society Quarterly in 1993. With more motions off the coast, you should have 4 times the precipitation in the Southwest United States. So again, have thicker soils, more organic matter, more vegetation. This is all going to result in a huge amount of soil carbon dioxide. Then as this water, as it comes down into the cracks, it does change a little bit, but there's variables along the flow path. But regardless, when it gets down to the cavern, it's going to have a high amount of carbonic acid that's going to mix with that calcium from the walls for calcium and carbonate ions. So the possible flood variable aftermaths, I've already mentioned, after leftover sediments with high organic content would greatly aid the development of caves by increasing the soil carbon dioxide. Also, another variable, very warm rock. I indicated to you about 1,800 meters of sediment and sedimentary rocks was eroded from the continent during the retreating stage. Well, there's what's called a geothermal gradient where the temperature increases with depth. If you rapidly take off 1,800 meters, the rock at the surface And even down below where the cave is going to be very warm to hot. So you're going to have hot rock for a while. And this is going to make a major difference in that all these speleothems can grow rapidly from this effect. And it's found that where you find these big columns, which is the vast majority of where the thickness of the speleothems is in these columns, a lot of times when you look at the surface, there's a little valley on the surface. As Hill and Forte say, typically the largest columns in it's Ogo Cave. There's 300 caves in New Mexico, are lined along sealing joints. A joint is a crack in the rock, and that's where the water is going to drip down pretty fast. But the greatest amount of water is dripping into a cave. Hill correlated the location of the most massive columns and stalagmites in Ogo Cave, New Mexico, with a valley on the surface. The joint along which the valley had developed is the same as that along which the massive travertine, that's a calcium carbonate, developed. In other words, after the flood, it's these little valleys on the surface that probably have the most organic matter. And therefore, and then there's a joint there, and then you can have rapid formation of soil carbonic acid, comes down in the limestone, picks up calcium, and forms the columns. So there is a correlation. I think that's a good indication of a rapid formation due to leftover mud with high organic matter in the flood. And of course, I don't know if this is the Cave of the Swords in Mexico. That's a person for scale. These are gypsum, and they form differently than calcium carbonate, but these formed rapidly, but they claim, based on what's called fluid inclusions, that it was formed by the cave walls were hot. They say that these things are about 12 meters long, 4 meters wide, and weigh 55 tons. And the temperature of growth, depending upon the fluid inclusions, were 47 to 54 degrees centigrade. That is really warm. Therefore, that's why you can have rapid growth. In this case, it was gypsum in the form of these swords. In other cases, it'd be rapid formation of calcium carbonate. So early into the mid-ice age, you would have a number of features conducive to rapid cave formation. Warm winters, cooler summers. So there'd be much more precipitation because of the warm ocean. Like I said, in southwest United States, I made a rough calculation of about 4 times the precip in southwest United States, where New Mexico is located. You'd have thicker soils resulting in high drip water calcium. Very warm cave temperatures, and probably because of the storm activity in the ice age, it'd be able to ventilate, suck out the carbon dioxide. So you have generally low cave CO2, and you have much higher drip rate because you have much more precipitation, and you have thicker water film, of course, and the relative humidity, don't know about that one. But anyway, based on all these variables, I made a table, which I hope you can read. Didn't come out right, but based on 6 variables: equitable temperatures and more moisture, 1.5 times 3 times that of today. Another variable, thicker soil and more vegetation, 1.5 to 3 times. Higher cave temperatures, 1.5 to 3 times the current rate. Greater ventilation, 1.5 to 3 times. Much faster drip rate, 2 to 6 times. These are just crude estimates. Thicker water film, 1.5 to 3 times. It all adds up to growing up probably around 100 times faster than today's rate. So they can form early and mid in the ice age. By the end of the ice age, climate changes considerably. So things don't work out like this. So it's slow way down. But so you can get your speleothems early and midway in the in the rapid post-flood ice age. So I'm going to conclude all this. There's a lot more challenges I can talk about. By the way, I'm doing research on quite a number of I do research on maybe a half dozen projects at the same time. Anyway, this is the take-home message. Bringing back the flood and adding the post-flood rapid ice age can solve numerous challenges which assume uniformitarianism. We've got to remember, they're assuming present processes, the present environment. And they say that therefore the flood is wrong. But they can't do that. They're using present processes. The flood was a gigantic catastrophe. But they always assume uniformitarianism. Also, often the challenges are challenges also to uniformitarianism. They have problems explaining many of these features, like coal, for instance. Anyway, if you want to know more about it, we do have answers to lots of things, as many of you know. There's a number of these answers book, but here's my favorite, the Creation Answers book by Creation Ministries International. Those are generally 3 to 5 page answers, but if you want more in-depth answers, John Reed and I edited this book, Rock Solid Answers. Got to read that. The Biblical Truth Behind 14 Geological Questions. So we answer 14 questions. This is an edited book, so we have a number of authors besides myself and John Reed that wrote chapters in here, like about reefs, paleosols, stuff like this. Anyway, that's all I have. I'm open to questions and answers now.
Mike, that's a great book right there, Rock Solid Answers. That has been a huge help for myself. I've actually got it around here on my bookshelf. And I want to say, great presentation, Mike. It's a blessing to have creationists such as yourself working so diligently to answer these challenges. And I want to say before I get to these questions, I love your approach to these challenges. As you pointed out in your presentation, that you look to them as research projects.
Mm-hmm. Yeah.
So I'm sure you would agree there's just not enough time in the day, unfortunately, to get to all the massive number of research projects we want to. So
that's right.
if only we can live as long as our biblical patriarchs, how much more we could do in terms of research projects.
Yeah, right.
So we've had a great chat. So much great information, Mike. Very rewatchable. I really appreciate it. And we've got a ton of questions. So what we're going to do is I'm just going to get right into them, and we'll get through as many as we can. Most of these, just looking at some of these questions, Mike, you could probably do a 1-hour presentation on alone. So what I'll do is I'll start with this question. We had a couple questions come in even before the show. They were left in the comment section.
Wow. Here's one. A lot of comments.
Yes. Yeah, there's a question here from Sam Schultz. I hope I pronounced that right, Sam. He sent this question in before we went live, and his question is, an evolutionist claimed that the mud flume experiments of Schieber, I probably mispronounced that, only show 27 centimeters or less speed for mud. And that's not the million times speed they claim the flood needs. I know you have talked about density waves. Would you please elaborate? Would more experiments with waves help? I'm just reading it word for word. I think I'm not sure if that makes sense to you, Mike, that question.
I go to the beginning again. I'm not sure what I missed the first part of that, or I'm not sure about what he said.
Yeah, he said an evolutionist claimed that the mud flume experiments of, and it's spelled Schieber, only show 27 centimeters or less speed for mud, and not the million times speed they claim the flood needs.
They're going 27 centimeters a second. That's Schreiber, I think. Scheiber.
Yes, I think so.
Okay. I'm not familiar with that particular experiment, but
he does elaborate. He says, I know
yeah,
they open.
I think I wrote an article on something like that not too long ago. That was just one way to do it, to form the layers. Yeah. Okay, I think I understand. Keep going.
Okay. But he just elaborated and said, I know they opened the largest wave flume in China in 2015. I'm not sure if that helps at all, but if say I'm going to go to the next question. If you are in the chat still and you want to try and elaborate, then go ahead. But I'm going to go to this next question here that came in near the beginning from Jerome. Thank you so much. He says, question for Mike Oard. Is ice considered rock? Example, hailstones.
If you got hit by one, you'd sure know it.
Yeah, I'm sure it'd feel like you're getting hit by a rock.
You can consider it kind of like a plastic. It'll flow under pressure and deform. But otherwise, it's pretty hard. But it's not rock. It's unique in itself, but it's hard when it's frozen, of course. But you put pressure on it, it'll flow. That's how glaciers flow. One of the ways glaciers flow, by the way.
Right. Okay. Thank you for the question. Thanks for that, Mike. Here's a question that comes in from Joe Wilson. Her question is, does Mike think the original creation was one supercontinent or more than one?
Oh, good question. If you read Genesis 2 carefully, it does not say there was one continent. It says that the seas were gathered into one place. So what does that mean? I'm not quite sure, but I know one thing. It doesn't say there's one continent before the flood. There could be, there could not be. And I'm going to, at this point, say I don't know. And that's what I've been publishing for years. And as I gather more data in these research projects, because that's going to be that's going to kind of be a side issue later on. But the seas in one place, I kind of look at that as kind of like today, in that they seem to be connected. They're in one place, but seas are kind of off bodies of water like the Mediterranean Sea, but everything's connected. So it almost seems like the ocean was kind of similar today in that it's all connected, but yet there are pockets that are slower moving, kind of cut off from the main thing, but still connected. Maybe like you think of the Mediterranean Sea. Anyway, I'm just going to say I don't know on that one.
Okay, I appreciate it. I appreciate that. Is a good question. Good answer, Mike. Here's a question that came in from Douglas. Thank you for your question, Douglas. He asks, how are wind and water gaps formed?
Yeah, I got a book that includes that, including an ebook on my website. And Flood by Design talks about it. Anyway, as the floodwaters are draining and they're going over a ridge, perpendicular to a ridge, they channelize. When they channelize, they speed up because the same amount of water has to go through more narrow areas. As say that, I have this stuff on my computer, but it take me time to access it, showing a block diagram. But as the waters are draining and say a ridge is coming up, the water's channelizing and the ridge is exposed. So the channelized water speeds up, and erosion is approximately the fourth power of the velocity. So you erode out a gorge really quick from the top down. And at the end of the flood, that's going to be the low spot. So rivers are going to go from one side of the mountain to the other, right through the gorge, through the water gap. Now there are wind gaps, where the water was rushing through it, but for some reason it got diverted and quit going through there and didn't dig it down far enough, so it's left high and dry as a wind gap after the water's drained. So only wind goes through it. That's why they call it a wind gap. So that's how they would form during flood drainage, during the recessive stage of the flood, mainly during the channelized phase.
Well, thank you, Mike. I love how informative your answers are. I could learn from you all day. So I appreciate that. I appreciate the question from Douglas. And here's a question that came in from George Bond. And he asks, why don't all layers show signs of erosion if they are millions of years old? So it essentially sounds like a good line of evidence for the global flood.
Big problem for the secular scientists. When you see sedimentary rocks, they're practically always one layer flat on top of another. Yeah, for thousands of feet, Grand Canyon being a typical example. In fact, I got a quote that, I have lots of presentations where I show stuff like this, but I have a quote from 3 secular geologists who wrote an article on the origin of the Teton Mountains in northwest Wyoming. The southern and northern part of the Teton Mountains are sedimentary rocks that used to be on top of the granite and gneiss that got eroded up there, but it's still to the south. And they say that there's 2,000 feet there, and it's flat, one on top of another. And it says they have the appearance as if they were deposited in an uninterrupted sequence all at once and without any breaks. And that's what we expect during the flood. They say, no, we can't believe that. So they put 200 million years there. But if that was the case, where's all the erosion? I mean, some of these environments they claim they can tell the environment from these things. I think they're just based it on uniformitarianism and guesswork. There's terrestrial environments and shallow marine environments. That's most of the environments they have. And in those cases, you should have valleys and cuts formed in hundreds, even thousands of years. But millions of years? That's one of our strongest evidence from the sedimentary rocks that uniformitarianism and deep time are false. The flat gaps, Ariel Roth has written a lot about that. You can get it on the creation.com website. His articles, flat gap, it's typical. It's worldwide. You just don't have to point out Grand Canyon, the flat layers, or the Tetons, southern Teton Mountains, but all over where you see it. What you do see is that after they were formed, then they were deformed. In other words, pushed up, fall down, cracked, broken up. But they were originally laid flat, one on top of another. Powerful evidence against deep time and uniformitarianism.
It really is powerful evidence, Mike. And in your experience, how do the critics respond to this line of evidence? What's their best response? Are they mostly ignoring it, coming up with rescue devices?
It's practically ignored. It's almost totally ignored. I hardly ever read something. I've read about the Grand Canyon. There's some areas where you see a little scour mark, and they claim that's from a river, and so that's the evidence of time. Or you see maybe some chemical reactions at the top of the Redwall Formation, and therefore that means there's a lot of time up there. Yeah, I mean, we have a lot of chemical reactions during the flood. In fact, I think we can really use several creation chemists, because there are a lot of chemical problems I run into about in the flood. And so they point out things like that as trying to say there's a lot more time there, but those are minor. They miss the big picture, the elephant in the room. The vast majority are just flat as a pancake.
Right.
And sometimes they say there's 10 million years missing at that gap. And there should be a lot of erosion there. In fact, you can erode at the present erosion rate, you can erode all the continents down to sea level in only 10 million years. That's a minimum, because there's a lot of caveats to that. Because as the mountains get smaller and smaller, the erosion rate decreases. So, but but you can put a maximum on it. So I've seen several secular estimates of 23 million years and around there. I've been more general. I say 50 million years is a maximum due to these other variables, which I've worked on. It's on my website. I have a whole part on the section on that. And so
I'm gonna make sure to link your website in the description box as well, Mike. So you mentioned mountains, and I think this would be a good question to go to next then, Mike. The question is, which model best explains the formation of mountains and valleys, the global flood model or uniformitarianism?
Well, I suppose the uniformitarians can explain valleys by slow erosion over millions of years and slow mountain uplift for the mountains. We have to form them rapidly. And during the late Cenozoic, most of the mountains of the world uplifted, 40,000 feet for some of the mountains in the Rocky Mountains. Late Cenozoic, which is why I put the flood post-flood boundary most of the time at the top of the late Cenozoic. But we can form those valleys rapidly during the channelized flow of the phase. The origin of valleys was one of the early questions that or challenges that the secular scientists gave in the early 1800s, saying you can't explain the origin of these deep valleys because look at that river down there; it couldn't erode that fast. Well, look what they were doing. They're thinking of uniformitarianism. Yeah, of course. But if you had a channelized flow, you can carve that valley almost instantaneously during flood runoff. And you form water gaps, canyons. You can form all this really fast during the channelized phase of the flood, the last phase of the flood. I hope I answered that question. I got kind of little off on a tangent a little bit, but the original question is, how do they explain the flat layers? I would say in general, they ignore it.
Yeah. And like you said, it looks like when it comes to the critics, it always goes back to those uniformitarian based assumptions. The key is the present to the past. And so they miss these great answers that flood researchers like yourself have provided.
Mm-hmm.
It's 2 Peter 3, they deny the world that then was being overflowed with water perished.
Yeah. I want to back up to that original question.
Sure.
Was he trying to ask of how you form layers in thick mud rocks? I was wondering.
Is this the question all the way from the beginning, or the one we just did, Mike?
No, the very beginning, the first one you did. I'm still thinking about it.
Yes. He did say, he did say something in the chat. Oh, here we go. He says, so to clarify, I appreciate your clarification, Sam. He says, so to clarify, can mud rocks be deposited in moving water in addition to still water? Can the floodwaters slow down enough to deposit mud?
Oh, yeah. Okay. That's yes. You can form them in moving water and still waters, but if it's moving too fast, you won't form layers. Unless you're really dumping a lot of mud, and if you have a huge amount, it'll just totally saturate the flow, and it'll have to be deposited. But mud can flocculate. They found out that it's very easy to. What they do is electrical charges cause them to coagulate and form larger particles, and they come out a lot faster. We have some thick mud layers in the western United States, Mowry Shale. That sort of thing, and I've been thinking about that, and I think they formed probably late in the early flood, when the water slowed down and became calmer in a lot of areas. In fact, I believe the very early flood, the first 40 days, were pretty violent, and not much was deposited except in deep pockets. Rifts and basins. I think a lot of them formed by meteor impacts. Down in pockets, the currents would be going a lot slower. So mud and sand and other things can be deposited in those pockets. But higher up, I think there's just too much commotion in most places for those sediments to collect. And those are mostly the Precambrian sediments that are down there now. And then things kind of calmed down after the great unconformity was formed. And then you had rapid deposition, like in the West here. If you look at Grand Canyon, which many are familiar with, you see 5,000 feet of sedimentary rocks. But you go to the Grand Staircase, you have evidence that you probably had 10,000 feet of sediments above that got eroded off as a sheet first before Grand Canyon formed. So you had about 14,000 feet of sedimentary rocks, and they're practically all horizontal all the way up, indicating that it was deposited in an area that was fairly calm. And that's how I think most of the mud formations, a lot of them that became shales, formed by flocculation in generally calmer waters. Probably some currents, but not strong. If they're too strong, they will of course erode and won't deposit. So, yeah, I think I provide the adequate answer to that.
Absolutely. I appreciate the clarification, Sam, and great answer, Mike. I appreciate that. So here, these questions are flying in like crazy. There's a couple here that I will put on screen because let me see here. Question from Jamie Russell, and he asks, can the winding of Grand Canyon be explained quickly?
Oh, yes. I have a whole book on the topic called The Grand Origin of Grand Canyon, if you want to know more about it. There's several problems that I address. Essentially, the Grand Canyon is a water gap. It's a long water gap. There are well over 2,000 water gaps across the earth. Grand Canyon is not the deepest water gap on the earth by far. Some of the water gaps through the Himalaya mountains are about 4 miles deep. And even in North America, the deepest water gap is Hell's Canyon, the Snake River between Oregon and Idaho. That's 50 miles long. The Grand Canyon is probably the longest water gap. So Grand Canyon is a water gap, and it can form rapidly during the channelized flow of the phase as it channelized through there across those plateaus, and it cut them from the top down.
Well, that looks like it's another book I'm going to have to add to my collection.
You can get it from the Creation Research Society.
Okay, perfect. Because we do, I'm going to link all of those in the description box because we got a ton of people specifically asking for links to all these different books that we've been talking about. So those will be in the description box, ladies and gentlemen, after the show. So here's another question that it looks like I think I might be able to put onto the screen. Let me see here. You did mention this.
You do that.
Yeah. And then it's unfortunately the earlier questions, they're gone because the chat's been so lively. These are some more recent ones. And Science Rules, you did mention this as a challenge, I believe, at the beginning of your presentation, Mike. He asks, how did the flood form angular unconformities like the famous one at Sakar Point, Scotland?
Oh, that was part of my early part of my presentation.
Right.
Anyway, what I think is that you had rapid bowing up of the sedimentary rock, and the currents are going fast, and they just sheared it off, and then a layer of horizontal sedimentary rock were laid on top of it, and we have things like that in a lot of different places. A lot of times they're not vertical like at Sicker Point, the bottom. A lot of times they're at an angle, maybe a 30-degree angle or various angles. And then another, but you got to realize we had a lot of tectonics during the flood.
Right.
Just if you got, we know that there are 200 meteorite impacts that we find in the strata, and some of them fairly large. That's going to cause tremendous deformation of the sedimentary rock. In fact, I've been reading about what's called the belt supergroup rocks in western Montana, Idaho, and Washington and adjacent Canada. It's a huge area, very thick. And they talked about there's Salmon, Idaho, in the Beaverhead Mountains, which are along the Montana-Idaho border, of a fold that rose up 10 kilometers. It folded, and some of it was overturned. 10-kilometer fold. That is so huge. I got to wrap my mind around that. I'm doing more research on this whole area at the moment. And so I come across that just the other day. And so you can have rapid uplifts and then sinkings and shearing off. So you can form angular unconformities in a lot of different places. Not a problem rapidly.
And your uniformitarians assume continental drift. And correct me if I'm wrong, Mike, would we as proponents of the global flood, at least during the time of the flood, would we assume continental sprint, meters per second plate movements as compared to what we see now, right? Your snail pace. What are your thoughts on that, Mike?
Oh, I have a lot of thoughts that could take me hours, but I'm just going to sum it up in that that's called the catastrophic plate tectonics model. And I will add that most creation scientists believe that model or lean towards it. A lot of them don't believe it wholeheartedly. I know that from talking to them. Since I've been doing research in neurosciences for 45 years, and I've read a huge amount of secular literature, I come across, most of the time by accident, many problems against plate tectonics, and that would probably also be for catastrophic plate tectonics, even though catastrophic plate tectonics could probably solve some of these problems. I run into so many, and I published them in this Creation Research Society Quarterly, in the book Plate Tectonics, A Different View, which you can get from the Creation Research Society, which I wrote 40% of. John Reed was the editor. And so it has evidence, but it has a lot of evidence against it. And I would like to see the researchers do the research to solve these issues, and it's slow in coming. And so I run into these things a lot of times by accident. And so I can only believe. I was a weather forecaster for 30 years, so I give probabilities for things. I don't jump to say yes or no when I don't have enough evidence. So I give it a probability. So like 30% chance it'll rain today. Right. And so I give catastrophic plate tectonics a 20% chance of being correct, 80% chance of being wrong. This will probably shock some of you out there. Oh, before I get into that, why? I'll give you one reason why. I believe that in meteorite impacts followed by differential vertical tectonics, where rock goes up and rock goes down. It drains the floodwaters. That's the last half of the flood. Early in the flood, it was impacts. And I certainly don't believe the number of impacts extrapolated from the moon to the earth, which would be 58,000, 30 kilometers in diameter or greater. It's way too much. It melt probably melt the mantle of the earth. We have that many quickly. But I believe in maybe about 1,000, and I think there's evidence for them, and I've published some of this evidence. But anyway, people are probably shocked, and my position is well known, by the way. It's I'll give them one piece of evidence. You have the Pacific Plate, the Pacific Ocean, and you have the North American Plate that is to the east and to the north, wrapped around it. And so the Pacific Plate is moving about 7 centimeters northwest in relation to the North American Plate. So if there was a lot of time where that moved, or catastrophically moved in catastrophic plate tectonics, you should see, okay, I got to back up. There are deep sea fans that erode from a continent out onto the deep ocean. And there's 3 of them that I mentioned in an article about 6 years ago. I published that in the Journal of Creation. You can get it online, creation.com. But there's a fan called the Zodiac fan. It's practically out in the middle of the Pacific Ocean. And the current directions and the channelizing indicated that it came from Alaska. And it's dated Cenozoic. And it crossed the Aleutian Trench, which it couldn't have crossed. If it came from Alaska, it should have filled up that trench, but it's on the other side of the trench, south of the trench, and all indications it came from the North Alaska. So, but then when you look at that, if they date it for what it's 40 million years old. I'm using their system, or in catastrophic plate tectonics, it should have been off the west coast of the United States, well off, where it couldn't get sediments, and then drifted northwest off Alaska if there was actually motion. But it appears there was no motion between the North American and Pacific plate. It was just eroded from Alaska, and the Aleutian Trench wasn't there and formed after the Zodiac fan formed after the huge erosion of Alaska. There's a second fan in the northwest part of the Pacific. I think it's pronounced the Meiji fan, where it eroded from the North American plate onto the Pacific plate, and it's thick, and there's no deformation or little deformation in it, indicating there's no differential movement between the North American and Pacific plate. So there isn't 1,000 or 2,000 kilometers of motion between them like you would assume in the Cenozoic or sped up in catastrophic plate tectonics. So that's just one of many things. So for people that are confused about all this, is that there's a lot of unknowns in science. So I say that we should use the principle of multiple working hypotheses when there's a lot of unknown. That was propounded by the geologist Chamberlain well over 100 years ago, saying it's good to have a lot of ideas out there. Let's have a lot of ideas. Catastrophic plate tectonics, impacts followed by vertical tectonics, and get the data to try to prove these. And so that's a good thing. A good thing. It's not a problem having different ideas, because we all have different ideas. It's just that we need to demonstrate it. And like I said, catastrophic plate tectonics has evidence, and so that's why I believe at 20%. So that kind of sums up something I could talk about for a couple hours. But it's controversial, and I'll discuss it with anybody in charity.
Well, once again, so much good information, great answer. And I like those rules you live by. I completely agree. Well said. And I think that's why you have been so effective and successful as a researcher, specifically a flood researcher. So those are some great points. And so many questions. I think this is actually might be the record for the amount of questions that have ever come in, Mike. So people are really interested in your answers. And this is something you talked about a great deal in your presentation. And we've got a lot of people who are now just joining us. Ryan, the Raptor guy, asks if you could talk about the beds hypothesis. So I will say first off to Ryan, definitely go back and watch Mike's entire presentation. Tons of great information.
You came in late.
Yeah, you came late. So he's obviously aware of it. And Ryan oftentimes joins us and asks us great questions. He seems to be really up to date on the different models in young Earth creation. So I don't know, Mike, if you wanted to just kind of briefly recap it, or
okay, I'll recap it. In the flood, you have areas of rapid sedimentation, and in those areas, it forms so rapidly that the bottom of the sediments comes up to near the top of the floodwaters. And so a local drop in the level of the floodwaters exposes that freshly laid sediments, briefly exposed alluvial sediment. And therefore, you can form tracks on it, lay eggs, raindrop imprints, even mud cracks. Even a day of drying will cause a mud cracks. I've seen it in Tucson, by the way, after a rain. And so you can form these, and then another rise covers it all up to preserve it. So that's in a nutshell. You can read all about it in my book, Dinosaur Challenges and Mysteries, or you can go look at this presentation, which is actually still a summary of that book.
Yeah, I would say go rewatch the presentation and get that book. That book was one of the specific ones people were asking links for, so I'm going to provide that as well. Here's a question that just came in from Science Rules. I guess it has to do with dating methods. If both strata were deposited in the same year, why do they date so differently? In your opinion?
Well, they date strata mainly by the fossils in it. And they're dated indirectly by radiometric dating methods of igneous rocks. And I think these igneous rocks have different chemical signatures. And so you get different dates out of them. That's still a huge area that we are still doing a lot of research in. We can account for the millions of years they give from Humphrey's research on helium and zircon crystals. And we know that a lot of dates are wrong, and there's also a circular reasoning tendency. But I'm thinking that a lot of it are chemicals. Say one igneous rock has more argon in it and than another, and it'll be dated older, obviously, in the potassium argon method. And their assumptions of that they would totally become zero argon are wrong. They don't use that anymore anyway. There's always some, and they got to go to other assumptions. But if you want to read a good book on it, you can get Cups's new book put out by ICR. Yeah.
Rethinking radiometric dating. Okay, I'll take that.
It's a great book. It's a bit in depth, but I just read it, and I knew. So I've read a lot of stuff on it, but he kind of summarizes all this why you can't really trust the dating methods, and so you can have things that are dated millions of years apart that happened in the flood.
Well, haven't they attempted to date rocks of known age, and yet they get millions and millions of years?
Oh yeah. In fact, he points out some of that. The rocks in the Grand Canyon, and then the volcanic cones and stuff on the northwest rim, mostly on the northwest rim, that are fresh lava. You date some of that as 1 billion years old, and it's pretty fresh. You date a volcano in New Zealand. I can't pronounce it. Snelling did this research. Nagara, something like that, and in northern New Zealand, and they got dates of millions of years. And then there was one date, I think the lead method, that gave several billion years. So if they can't, this is the takeaway message of this. If they can't date correctly rocks of known age, why do we believe them for their dates on rocks of unknown age?
Exactly my thoughts. We're supposed to trust the dates derived from rocks of unknown age, and yet, as you're pointing out, we're getting these incredibly divergent dates on rocks of known age. So I think
I will admit we do need more research, because there's a lot of dating methods out there, right, even besides the radiometric dating. And some of this is being done like thermoluminescence. Vernon Cupps talks about that. There's a lot of what's called quaternary dating methods that I've seen. They all have issues and assumptions and so forth. So, but we do need more research. But in answer to the question, it really doesn't matter whether one igneous rock formed at the same time of the flood as, say, 100 million years based on the chemicals in it versus 1 million in another. It's not an issue.
And if we're getting detectable levels of C14 in samples such as, I guess, coal, diamonds, fossils that evolutionists say are, millions to billions of years old.
Yes.
Right. So that would, I guess, again, be a problem for their point of dating methods. I imagine that shouldn't be there if they really are millions to billions of years old.
Oh yeah, every time they date coal by a carbon-14 method, they do it to calibrate their instruments, and we've done it. You get detectable carbon-14 in it when it should be all gone within a maximum of 80,000 years. If it's over 80,000 years, all carbon-14 should be gone. But they claim contamination a lot. But come on, hundreds of times. I mean,
right.
Researchers don't go and sample a coal that they know has a crack in it where a young carbon came down in. They will go through a sample that's uncracked. They'll collect it. They take great pains to find a sample that's pure and not contaminated. I mean, it still can happen, but not all the time.
Right.
So, and they date coal anywhere from 15 million to 350 million years old. And of course, diamonds are several billion years old, and there's detectable carbon-14 in diamonds. So there's lots of problems with the dating methods.
Right. Great points. Well, here's a question that came in a while ago from Chris Peacock, Mike, and unfortunately I can't put it on the screen because it's a question from so long ago earlier in the stream. But he asks, how can a flood with the power to split the continents and push Everest to where it is also be gentle enough to preserve raindrops?
Well, because the flood wasn't chaotic everywhere at all the same time.
Right.
You had the early flood. It probably was very violent over most areas. I would say not all. But after the mechanism slowed up, probably I take about 40 days is when it started to slow up. Then you had rapid sedimentation. Things were calmer. So you can have oscillating sediments. You can have deposition of thick muds, these sorts of things. And Mount Everest, of course, that whole area was under sedimentary rocks during the flood, and it came up out of the floodwaters late in the flood. I need to get back to the original question. I got off on too much.
No problem. Let me see. Yeah, no, I think you answered it well too initially, that it obviously wasn't equally chaotic on all parts of the earth during the flood, because the question was, how can a flood with such great power also at the same time be gentle enough to preserve raindrops?
Well, yeah, because the raindrops are preserved on the beds. During the when you have them exposed, you can have raindrop imprints that are formed on them. And by the way, you find these raindrop imprints clear to the late Archean, which is about 2.6 billion years old, according to the secular time scale. And this tells me that much of the Precambrian sedimentary rocks are from the early flood. I see a question I can answer real quickly on the right here. How could
absolutely.
A flood deposit layered fossil forest like in Yellowstone? Well, yeah, because that breccia there was deposited in one area, broke up, and was redeposited as huge flows over such 9,000 square miles. And above it, you had the log mats floating, and they were sinking as it was depositing these breccia flows all 6,000 feet. You find layers. In fact, you find 9 areas in Yellowstone that we know of where you have a lot of them on a cliff, but you find isolated ones here and there all through that Absaroka Volcanics. So that's how the log mat and rapid sedimentation in fairly deep water. I have a talk where I actually have a diagrams kind of illustrating this principle. But anyway, you were going to show me another question. I just quickly caught that one on my eye.
Yeah, no, I appreciate that. That's a fascinating answer, because I've personally heard some of the skeptics and critics of the global flood model look to that argument that you just answered as just a number one argument against the flood. And as we can see here, there is an answer.
Yeah.
So I appreciate that. Yeah, this question here comes in from Landon Freeman. He says, if you came across a Christian who believed that the flood was local, what would be the first main piece of evidence you'd present as a counter argument?
Well, I'd ask him, does he believe the Bible's account of the flood? And secondly, I would say based on that, it says that all the animal, two of each kind of animal came to the ark. And there'd be no point of collecting animals at all if it's a local flood. No animals at all. You don't even need an ark. Just flee to the mountains. There's at least 9 reasons right from Scripture against a global flood. For instance, the ark landed in the mountains of Ararat. If it's a local flood, it'd end up in a floodplain or out in the ocean. It wouldn't go backwards up in the mountains from probably where the flood supposedly would originate. It's a local flood.
Right.
So forth and so on. And then you look at the sedimentary rocks, and they're deposited one layer upon a layer over vast different areas, like the Tapete sandstone, the bottom layer of Grand Canyon on top of the granites and metamorphic rocks, about 200 feet thick. It's spread over half of North America as a sand. Up in my area, it's called the Flathead Sandstone, lying on granite, and the Belt Supergroup, which is a Precambrian rock that I believe formed earlier in the flood, but it's mostly on the bedrock of the upper crust, the granites of the upper crust. So that's not slow processes of erosion and deposition over millions of years. Slow processes are you'll find a little bit of sand that changes to gravel, then the mud. It's just a laterally, horizontally, and vertically. It's just great changes. But you see this layer of sand spread over half of North America. I mean, the sediments themselves scream flood. So not only does science of geology say that, but also the Bible is clear that it was a global flood.
Right. That's a great answer. And you mentioned sand there. And here's a question. And there's even an article on this as well, where the critics of the global flood have stated that it only takes one example of desert sandstone to disprove the young age of the earth. So I thought that was an interesting question to ask you. What are your thoughts on that?
Desert sandstone. Okay. They claim a lot of sandstones in the geological record are windblown from a desert. A lot of this is old research based on that, and it's kind of been led a life of its own, because they see these big cross beds. Mm-hmm. See, as sand moves, it forms kind of a delta feature as it moves out. They're called cross beds. And a lot of cross beds are 30 meters tall. I mean, that imply a huge flood to deposit that. I mean, at least the water would have to be 5 times as deep as the cross bed. So they automatically got a bias that, this can't be a marine deposit. Actually, now new information shows that marine sand waves can have huge cross beds too. So, but anyway, they've made that claim. But John Whitmore and Ray Strom and colleagues have written some great papers you can get on the Answers Research Journal, showing that the classic area of a windblown sand, the Coconino Sandstone near the top of the Grand Canyon, is obviously a water-laid deposit, because it has mica in it, and feldspar, and a lot of other things. In fact, a lot of the statements made by the top researchers on that sandstone were half correct or wrong, and they didn't do a lot of good research. And so I think, have demonstrated positively that it's a marine sand. And so I don't believe there's any desert sands in the rocks at all. But that's an ongoing research project, because we got to check other ones like the Navajo sandstone,
right,
and things like that. But in fact, the Navajo sandstone has a lot of indication of water-laid sediments in it. It also has a lot of dinosaur tracks, as petrified trees. I mean, it has a lot of evidence that is laid down in water. So, and it's massive. I mean, there's areas where there are hardly any shale interbeds, like you see in Zion. I mean, it's just massive sand that's been cemented to sandstone. So, yeah, we don't believe there's any such thing as desert sands. And we have evidence of the classic case, the Coconino sandstone, that it's not a desert sand.
Well, that's a great answer, because those are the two big ones they look to is the Coconino sandstone and the Navajo example that you pointed to. And you demonstrated that yes, this can certainly be explained through a global flood model. So that was a really important answer you provided the audience, because it's an argument commonly put forth as like a one and done against the flood. So I appreciate that one.
They have a lot of those things, and like I said, we have answers, and we're still working on answers, but we do have a lot of answers to a lot of these questions.
And here's an interesting question, actually, that I have here saved. And let me see here, because there's so much. Okay, I got it right here. I'm curious as to your thoughts, Mike, because the question is, critics of a global flood state that a flood would have washed over everything equally. And so terrestrial creatures should be as abundant as aquatic creatures. But according to the questioner, we see shallow marine creatures making up most of the fossil record. Therefore, is this a problem for the Genesis flood model?
Well, like a lot of problems, it can seem like it, but we haven't got all the facts in yet on all this. And so we got to watch out jumping to conclusions. There are a number of answers to this. Like ecological zonation being one, is that it was zones, ecological zones that were buried. For instance, marine creatures first, and then going up to more creatures that swim, to more terrestrial features. And there's a lot of unique features. Now, I take the geological column as general guidance, broad scale evidence, but I think there's a lot of fine details that are not correct with it. But in a broad general scale, I take it. And what you find is in the Paleozoic, it's mostly limestone with marine creatures. Then you go to the Mesozoic, you find a lot of floating ammonite fossils, and then dinosaurs, and then Cenozoic has a lot of terrestrial creatures. Anyway, there's a pattern there, and I think ecological zonation, vertical ecological zonation, marine creatures live down lower and terrestrial creatures higher up. But there's a lateral zonation in that the trees that are formed the coals in the western United States are mostly from what's called angiosperms, or flowering plants, or probably coniferous trees too, but those on the East Coast come from extinct lycopods, different type of tree altogether. And so it almost seems like two different ecosystems deposited, difference, East Coast, West Coast. And I don't think we got good answers to that yet, but I think this research project I'm working on possibly could answer some of these. Namely, remember I said that at the peak of the flood, it appears we had 5,000 meters average sediments or sedimentary rocks on the continents. Average. And even in the continental, the Canadian Shield, you had Paleozoic rocks. We know at least because there's pockets of them there, like Hudson's Bay. So that was covered. So the question is, where did this sediment come from to reach 5,000 meters at the peak of the flood by day 150? Well, I am leaning more strongly all the time, like several other creation scientists, that, like, let's take North America, which I'm familiar with, that North America was actually part of the ocean, the pre-flood ocean. And out in the Pacific Ocean was actually the landmass was mainly out there. And that when the flood first occurred, it was the marine creatures in the U.S. that got covered up first. And then you had currents coming from the west, from the east first for the Paleozoic, and then the west in the Mesozoic. And that came from off the Pacific, and that brought in creatures that were out there on the land masses, like flowering plants, dinosaurs, that came up and ended up on top of the Paleozoic marine creatures in a lot of places, especially the Western United States. And I think it was different on the East Coast, of course. But so I think some of these trends can be explained this way. These are thoughts that are just entering my head in the last month. So I think we got ways to explain that, but I have to work it all out, and it might take quite a while. But that's an idea I have, that a lot of the ecosystems came from off the ocean onto the current continents, which were under the water early in the flood. And therefore, we have marine creatures first, followed by more terrestrial creatures on top of the marine creatures.
Yeah, that's a great answer. And that pretty well answers this question, too, about, how do we answer the fossil record being claimed by the evolutionists to have been sorted in an order convenient for evolution. And as you point out, this burial by ecosystems and communities. And what are your thoughts then, Mike? Because don't we have evidence right from Scripture that in the pre-flood world, we may be dealing with different elevations because we have rivers that are flowing out of Eden. And since rivers flow downhill, would we expect humans on one elevation, a different ecosystem than, let's say, dinosaurs?
Oh, yeah. You can have dinosaurs living in low country just off the Pacific coast. Once you form the Paleozoic rocks, marine creatures deposited mostly in North America, which are widespread in North America. The currents come from the west, deposit that ecosystem there with flowering plants, forming coals later on, and dinosaurs. And then I don't know how the people would get in this, but a lot of mammals, say, were at higher elevations further out, and they'd come out and then end up being deposited on the Mesozoic dinosaurs. There's intermixing in all that, by the way,
right,
too. So anyway, these are by the way, these are research thoughts, called speculation, if you like, that is current and ongoing, and is not meant to be a factual answer. But I think a reasonable idea that I'll share is preliminary. That's what I'm trying to say.
Right.
Some of this is preliminary, research ongoing.
Yeah, that's a great response. And something that came to mind is if we start from the account in Genesis, well, we know God created two human beings, Adam and Eve, and populations of animals. And I would imagine fully working ecosystems. So in your opinion, Mike, would we expect to find a lot of human fossils as compared to billions of animal fossils?
Well, that would be true. My wife's called me for dinner. Anyway,
no worries. My wife too. We can start wrapping up.
I can keep going. Anyway, I got suddenly distracted. Repeat that.
I guess, what are your thoughts on if we started from the Genesis account of origins? We've got God creating, he's creating two humans, but then populations of animals, I would imagine, spread out over the supercontinent. So wouldn't we expect billions of animals versus probably very few human fossils?
Yes, the Lord probably populated all these ecosystems with millions of animals already. I mean,
right.
He didn't have to start with two, but humans did. Yeah, from a statistical point of view, we shouldn't find many, but there's several possibilities why we don't find any. There's some human fossils in the rock record, even though there's been some equivocal evidence that they're there. I just don't know what to make of it. And artifacts found in coal. So
right.
There's stuff like this around. Some of it seems pretty good. I just don't know what to make of it total, and I haven't given it much thought. One possibility is that humans were deposited in the upper layers of strata. They being at higher elevations out in the Pacific Oceans, we'll say.
Right.
And they come spread and they're on the very top. And then when the retreating stage occurs, 1,800 meters average erodes from the continents, and they're at the top. And as they get down, turbulence and just totally pulverizes them down to molecules. So that's one. Another one is that it said that that the Lord could have just totally wiped out man by right away in the flood. I mean, the object was to destroy humans. So he could have done, say, with a lot of meteorite impacts hitting the right places at the right time so that there weren't hardly any humans left within, say, 10 days. I mean, that's another option I've heard said. But like with a number of questions, I'm going to say at this point, I don't know. I have ideas.
Right.
And I call it reasonable speculation, but not reasonable answers.
I would say some very plausible ideas. And that's what's so fun about, being involved in this creation versus evolution debate and controversy, is because there's so many active research projects, as you pointed out. And I personally find that to be fun. I like studying these issues as you as well, Mike.
Yes. Amen.
Now, I surprisingly, I looked over at the time. We've been going for 2 hours and 10 minutes. So time always flies by with you, Mike.
It does.
And you've done a great job. Our last show, we went almost 3 hours. I couldn't believe it. So we've got almost 10 hours, I think, of material with you. We've just gone rapid fire Q&A with you on some of the toughest questions. You did a great job. So I really appreciate that, Mike. And I think you've earned dinner, as your wife is calling you, for.
If you want, we can have just a Q&A session of some time. There's so many questions, and I haven't been able to get to a lot of them.
Well, what we can do, if you like, because these Q&As fly by, I can save the questions that we didn't really get to, and maybe, we can schedule just an audience Q&A where we just kind of deal with as many of these as possible. Because
that'd be great.
Yeah, I find this a lot of fun. This is, I think that's why time really flies by. So maybe we can, touch base through email and we'll get that going. Mm-hmm. We've even got people in the chat already saying question and answer would be great. So, and that gives already people are agreeing with us. So maybe to everybody in the chat, think up some questions. And you can even email me them and we'll set that up. Hopefully, sooner than later. So that being said, Mike, another fantastic presentation, so much great information, an awesome Q&A. To the audience, thank you so much for your questions. I think this is now our top show in terms of most questions asked. It was even hard for me to keep up. So I did my best. I apologize to those whose questions I didn't get to, but we will save those for a future show. Mike, I want to hand it to you for some final words, final thoughts, and thanks again for giving us your time.
Oh, you're welcome. Glad to do it.
Awesome. I appreciate it. I appreciate it, brother. So anyways, I'm going to let you get to dinner. My wife's calling me up for dinner as well. So well earned, well deserved. Okay. And to the audience, thank you so much. God bless. And Standing for Truth is out.